Electric generators and electric motors are probably the first device that was ever uh, comprised to use Faraday's law. And so it's uh, it's a duality in the sense that an electric motor can be used as an electric generator, and it turns out that the same can be said of the generator. An electric generator can be used as an electric motor. So the difference is that a motor changes electric energy to mechanical energy, and a generator changes mechanical energy to electrical energy. So let's look at how this generator works. And first of all, this is a little bit of just uh, it's not a real representation of exactly how a motor is designed. There are some simplifications that are done here. Actually, the motor has it so that the magnets are curved in a way so that the magnetic lines always go through this coil, excuse me, perpendicular to this surface. So they're optimized, but we can come up with a formula here for this. So let's start with Faraday's law equals negative N times the change in flux and we can write this as an integral negative N dt of the integral of the magnetic field dot differential area, and we can convert this to the differential of b times a cosine of theta. Now, the theta is related to omega. So omega is equal to d theta dt, and then theta we can say is equal to theta naught plus omega t. That's if we do the integral, do separation of variables, do the integral, and this is our constant of integration. And now, because b and a are going to be constants, we can take and change this to be E is equal to negative NBA times the derivative of cosine omega t plus theta naught. And that just gives us, in the negative sign goes because of the derivative of the cosine, NBA omega sine omega t plus theta naught. And you notice that N is a constant. It's kind of hard to change the windings once you've created the motor. B is a constant because it's due to the magnets inside. A is a constant because of the way the windings are built. And the only thing that can change is omega. And how do we do that? These are constants. Well, if I speed up the motor, change omega, make it bigger, then this omega outside is going to make the electric potential increase. And so that's the quickest way to actually increase our induced potential from the motor. So this one equation tells us a lot about how a motor will perform and how we can change the induced potential based on how fast we spin it.